All right, welcome to The Explainer. Today, we're going to pull back the curtain on something you see literally every single day, but probably don't think twice about: the printing on packaging. It's so much more than just slapping some ink on a box. It's this amazing mix of science, strategy, and some really clever engineering that takes an idea from a computer screen to the actual product in your hand. So, let's dive in.
Seriously, have you ever stopped to think about that? How does a perfectly crisp, colorful logo get onto a curved aluminum can or a crinkly, flexible bag without looking like a total mess? It kind of feels like magic, right? But it's actually a super fascinating process. And once you understand it, you start to see this hidden logic behind basically everything on the supermarket shelf.
Okay, so to get our heads around this, we're going to follow the package's journey. It all starts as a simple idea, just a digital file. From there, a really critical choice has to be made about how to print it. Then it has to get through this whole gauntlet of rules and regulations. And only then does it finally show up as the finished product you see on the shelf. Let's start right at the beginning, with the idea.
So yeah, every single package you see started out as just a file on some designer's computer. But a pixel on a screen and a drop of ink on a box, well, they're two totally different worlds. And to bridge that gap, and maybe more importantly, to avoid some super expensive catastrophic mistakes, everyone involved in the process, the designer, the brand, the printer, they all need to be speaking the exact same language.
And that universal language? Well, it's built on standards. You can think of them as the ultimate instruction manual for printing. They're what makes sure that the design created on a laptop in California looks exactly the same when it's printed in a factory in Germany. Honestly, they are the unsung heroes of the entire packaging world.
So what are these standards actually doing for us? Well, PDF/X basically locks the design file in place so your fonts and colors don't just randomly change on you. Then you've got ISO 1959-31, which is like a secret digital blueprint inside the file, telling the machines exactly where to cut, where to fold, or where to add that shiny glossy coating. And those ISO barcode rules, they're the reason you get that satisfying beep at the checkout instead of some frustrating error. Without this shared language, you just have pure chaos.
All right, once the file is all standardized and ready to go, we hit the next big decision. How are we actually going to print this thing? And it is definitely not a one-size-fits-all situation. Choosing a print method is kind of like a chef choosing the right knife. You absolutely need the perfect tool for the job. And in the world of packaging, there are four main players.
First up, we've got offset lithography. This is the classic choice when you need incredible detail. We're talking really fine text and super rich colors. The design gets transferred from a plate to a rubber blanket and then onto the material. It's the absolute go-to for those high-quality paperboard boxes, like for fancy electronics or cosmetics. Next is flexography. The best way to think about this one is like a really, really sophisticated rubber stamp. It uses these flexible plates, which makes it incredibly versatile, and the undisputed king of printing on things that aren't flat. Chip bags, those plastic sleeves on bottles, product labels. If it's flexible, it's almost certainly flexo. Then we have rotogravure, or just gravure for short. For this method, the design is literally engraved into a massive metal cylinder. The quality and the consistency are just unbeatable. But that cylinder is super expensive to make, so you only bring out gravure for gigantic print runs. We're talking millions and millions of candy wrappers or huge rolls of patterned film. And finally, there's digital. This is pretty much what it sounds like. Think of your office printer, but on a massive industrial scale. It uses toner or inkjet technology, and the key thing is there are no plates. That means it's perfect for short runs, prototypes, and quick changes. But its real superpower? It can make every single package unique, which opens up this whole new world of customization.
So you can see each method has its own really clear trade-offs. If you need that fine, crisp text on a premium box, you're going to choose offset. For the sheer versatility to print on a flexible chip bag, you need flexo. For millions of absolutely identical, perfect wrappers, gravure is pretty much your only option. And for, say, 1,000 custom boxes that you need by next week, that is a job for digital. So the right choice is always this careful balance of quality, speed, cost, and what you're actually printing on.
Now, choosing the print method is a huge step for sure. But the journey is not over yet.
Every package has to pass through this intense gauntlet of rules and regulations. It has to be safe for us, it has to be legal to sell, and, more, it has to be designed to be responsible.
Take food safety, for instance. In the US, the big rule is the no transfer principle. Basically, no harmful stuff from the ink can migrate through the package and into the food. The EU, on the other hand, is way more specific. They have these long, detailed lists of substances that are actually approved for use in inks. And some countries, like France, are even banning certain types of ink altogether, like ones based on mineral oil. And then there's the package's second life, recycling. And this is not an afterthought anymore. It's a huge deal. Major industry groups have created these super detailed guidelines for designers. They spell out exactly what kinds of inks, labels, and glues you can use to make sure a package can actually be sorted, cleaned, and turned into something new. And if you get this wrong early in the design phase, well, it can mean a really costly and wasteful do-over later on.
Okay, so we've got our standards, we've got our print methods, and we've got our regulations. Let's see how this all comes together in the real world by looking at one of the most common and surprisingly complex items out there, the good old aluminum beverage can.
So here's a classic problem. A brand designed this can with a beautiful, smooth color fade that went from side to side. But when it hit the production line, it just looked awful, streaky, and inconsistent. The solution? They had to apply the specific printing rules for cans. They changed the fade to run up and down, and they designed in these tiny, nearly invisible gaps between the colors, which are called reverse traps. And the result? A perfect-looking print and a barcode that scanned every single time. It just goes to show you knowing the technical rules is what unlocks creative success.
So why is printing on a can so tricky in the first place? Well, it comes down to this number, about 30%. That's the dot gain. When a tiny dot of ink hits that fast-moving, curved aluminum surface, it doesn't stay a perfect little dot. It spreads out. It bleeds, growing by as much as a third. This means designers have to plan for that spread. They have to create an image that's intentionally distorted so that the final version, the one you see on the can, looks absolutely perfect.
So what this all really means is that the packaging all around us is anything but simple. It's this carefully orchestrated performance of art and science. From file standards to print methods, safety rules to the wild physics of a curved surface, every single detail is a deliberate decision. So the next time you grab a can or open a box, take a closer look. You might just see the hidden story that's printed right there on the surface.